everybody ready for the last few minutes? Yeah. Okay. I'll try to make this fast, so apologies if I break the speed of sound, because it's going to be a really fast presentation. I've done this in 15 minutes. I'm going to try and do this in 10. So, why SQLite in Adobe Air? Well, SQLite is an embedded local database engine. It implements most of the SQL 92 standard, which is what is used in MySQL and other database engines. So what you know will be already in here. It's very lightweight, it's cross-platform, it's open source, and it's embedded in Air. So you don't need to take care of any installation whatsoever. No setup, no configuration, no server required. And one important thing to remember is this database is one single file. So anything you put in that file, you can easily synchronize with a server or any other client. So you just transfer that file and you have an entire database that you can connect to. How do you use it? 5 steps. The first one is to create a file reference. I talked about the file system API earlier, like you can create a file, and that file will be your database. Second thing is to create an instance of something called a SQL connection class. That SQL connection class will take a file and will treat it as if it's a SQLite database. Then once you have that, you need to create a SQL statement instance, and that SQL statement instance allows you to run SQL queries against that database. Third thing is to open the database, and fourth thing is to execute some SQL against that. And then finally, when you've done that, you get back a result, a SQL statement result. So this is all nice in text, but how does that look like in code? Well, the same 5 steps. So you import the file class, you import the data class, so the SQL connection and the SQL statement class. You create a file, that's what you see here, db file of type file is file.application storage directory. Every Air application has an application storage directory, which is a safe folder where you can save files in. So it won't accidentally get deleted by the user. And then you do resolve path contacts.db. And what resolve path does is, if the file exists, it creates a reference to it. If it doesn't exist, it creates the file itself. So either this function creates the file or it opens it as a reference. You create the instance to the SQL connection, so essentially saying I want to open a new database with this file. You create an instance of SQL statement, and the last line is SQL connection.open, and in between brackets we give the argument db file, which is our file we created. So at this point you have a working database connection with Air. So you can run queries against that, store anything in there, and it's basically there for you to use. So, next step, run something against that. Let's say you have a contacts database, has some contacts records. So what you can say in that SQL statement class is, say, SQL statement.SQL connection, and that expects you to give a reference to the database connection. So you say SQL statement.SQL connection is SQLcon, which is that database connection. You set the query you want to run, select star from contact, so you want to get back all the records, and you execute. Now, in this case, we get back the results immediately. I'll show you on the next slide what other options you have, because this might not always be the best case. So, if you get back results, that will be an array of objects, and the object field names will be the names of the field names in your table. Synchronous versus asynchronous. What you saw just now was a synchronous call. That means that your application gets blocked while it gets executed. But if you have to get a lot of results back from a database or do something complex, it will actually freeze your application and the user can't interact with it anymore. So what you want to do rather than this is asynchronous, which means you set up event listeners for this. And you have 2 types of events you get back from SQLite, and that is either a result or an error. So the result means you've got something back, your SQL statement was executed correctly. If not, you get back this error and you can handle it, prompt the user that something went wrong or do something else. And the only real difference apart from setting up these event listeners is that you call SQL connection.open async rather than just calling open. So when you call open async, the class will know that you're using events and it will dispatch it. So you're using asynchronously, which means your application keeps running and you'll get back events as soon as the results come back. SQL connection class, just to briefly tell you about this, it connects to the database file. It provides these events I talked about. It also provides schema access, so you can introspect databases and find out what tables are in there, what fields are in there, and you can loop through that and actually build a sort of a SQLite editor, which I'll show you in a minute. SQL statement is what runs the queries, so it allows you to execute SQL queries on that local database against a specific database connection. Also provides these events and supports result paging in a really nice way. Does everyone know what result paging is? Like getting back chunks of data rather than the entire thing. So that's very easy in SQLite with it. SQL mode, I'll just briefly talk about this. You can create the database, you can read it, or you can update it. That's something you can give as an optional argument when you open the database. You don't have to worry about that. The default is create, so it will create a database when it's opened. Storage types, so you can store different types in this database. A null object, an integer, real, text. Text is important, that's UTF-16 encoded strings. So that's a little thing you have to think about. Blobs is something you can use to store binary data. If you have byte array, let's say an MP3 or some image, you can store that in a blob inside of SQLite. So that's very handy. And also R has added some specific columns to SQLite. It's called column affinities, and those are specific ActionScript classes that you can also store in there. And it will keep the data type. So string keeps as a string, a number keeps as a number, a boolean, date keeps as an ActionScript date, XML as an XML class, XML list as an XML list class. So those are specific ActionScript affinities you have in SQLite. And the object, of course, an untyped object, an ActionScript object you get back. Parameters. Has anyone heard about the risk of SQL injection? A couple of you? Well, that's the case when you have poorly coded database connections. People could hijack that and basically mess around with your database. And there's a way to get around that with SQLite in R. You can have a parameters object where you add these parameters and they get replaced when the SQL connection gets executed. So as you see here, you have where ID equals at ID. That at ID is obviously not the ID value, but it's a parameter. And that parameter we replace with a variable, for example. And R will take care that that SQL statement is valid and won't do any harm to your local database. So if you do something like this, you might as well use these SQL statement parameters to make sure that your data is safe and your database isn't messed around with. You can use that @ symbol, the colon symbol, or you could just use it index-based. So if you do it in order, you can say parameters 0 is a variable, parameters 1 is another variable. So that's the way to do it. Result paging, I talked about, that's getting back, if you have a lot of records, getting it back into chunks. So let's say you have 1,000 records, you want to get it back into chunks of 10 or 100. The way you do that is very simple. When you call SQL statement.execute, you just give it a number. And that number is the amount of records you want back. So if you do select star from contacts, that might be 500 records. But in this case, because we say execute 10, it will give you back 10. And we have a simple method of getting back the next chunk. That's saying SQL statement.next. So it's not that you have to execute it again. You just say SQL statement.next and you get the next 10, the next 10, the next 10. Until you get back complete. SQL result.complete is a property, and that indicates when all the results have been shown. So if you have all your records shown and you can't call the next method anymore, you'll get that SQL result.complete. Last insert row ID is the last inserted row ID. Might be handy sometimes. Rows affected. If you delete something, you can get back a number of how many rows were affected, for example. Transactions. You can do transactions in SQLite. In R2, there's an advanced feature where you can nest transactions. To nest the transactions, so a lot more advanced things there. And transactions are basically a way of grouping together write operations to the database, because that takes time. If you have like 1,000 records to insert, if you do that one by one, that takes time for the database to respond and unlock itself. So what you do is you group that, and there's a big advantage there. Let's say you have a complete array of contacts you want to insert. So you loop through that with a for loop, and you execute every time. But you notice that in the beginning of that for loop, we have SQL connection.begin. So that begins a transaction. And after that for loop, we have SQL connection.commit. So it has grouped all those insert statements, and it's going to write it once to the database.